Hello, this is Ana Gabriela Pessoa, and my group is doing the circuit analysis project. We'll be using Kirchhoff's voltage law to analyze the circuit inputted by a user. A circuit analysis means figuring out voltages and currents in each element and is an important engineering skill that applies to the breakdown of complicated problems into simpler pieces, which is the core of engineering. The Kirchhoff's voltage law is a quick and effective way to analyze a simple circuit's direct application of fundamental laws. With this project, we will be basing the code calculations into the Kirchhoff's voltage law. The group will created a code that analyzes the user input in order to calculate these currents within each of their individual resistors. Now, to do that, we are given this function, circuit solver. As you can see, the function has I3, I2, and I1. This is how we are going to be calculating and using the equations to get our final results. Now we start with this, part 1. The user will input the resistor 1, resistor 2, and resistor 3, and voltage 1 and voltage 2. Now voltage 3 is blank and is not going to be inputted because in this particular program, we only have 2 voltages and 3 resistors. This code is really helpful for engineers who don't have time to waste and they want to have in hand a way to calculate their currents, their maximum and minimum of their voltages. And it's efficient because it's only inputting these 5 little things and we'll get the results in seconds. Now, this code will only work with 2 voltages and 3 resistors. Any other type of circuit would not work with our code. As you can see, we'll be calling the function to calculate the current. And we'll combine the voltages into one matrix. The resistors are also going to be combined into one matrix. And the currents as well. We use the cell array to display the values. And we set up the limitations for V2 in between negative 1000 to 1000. So anything below this or above this would also not work with this project. And to do this, we had to create this new matrix for V2 based on I2. The same thing will go for V2 on I2 and I3. And we'll set up a minimum and max for V2. Now, while doing this, we had a problem because we hadn't done this. So we were having issue getting the actual final correct numbers. And after analyzing it and redoing it, we realized we had not only to do this part, finding the minimum and the maximums, and then the minimum of the minimum and the maximum of the maximums, but we also had to put in the length and add in the counter. This counter helped us when getting the final result, because without it, we would pretty much missing out everything that we inputted beforehand, and we're writing everything on top of it. Now, the current values to the matrices for R3 were based on also what was given to us on the problem, 15 to 115. And as you can see, also using the counter, and we use size to get the new current matrices. Now, these two were created the same way. It could be X or Y or whatever. They were created to help with the calculation on the loop. This. And you can see the voltages were set up with zeros. And we did everything with the rows and the columns. And we added the nested for loops for each one of the currents with V2, as you can see here, with V2 for I1, V2 for I2, and V2 for I3. And here getting the maximum and minimum, combining the maximum and minimum again, getting the maximum and minimum, and this is the equation, like the calculation we had to do. And this is how we set up to show the results. It's going to be pretty much on a column for each one of them, and all the results are going to be shown. And we'll display that on the command window. And we're going to plot everything. The graph is going to show our result as well. So the conclusion with this project was that the relationship between the current and voltage, or between the resistance and voltage, is directly proportional. The method to optimize the voltage by simply adjusting the values of currents or resistance. So let's give it a run. And so our first case is gonna be, the resistance is gonna be 100, and the second resistance is gonna be 120, and the third is gonna be 65, and the first voltage, it's gonna be 12, and the second voltage, 9. Now let's get this. As we can see, this is our plot. And you can see has everything working. This is the minimum voltage for V2 and maximum voltage for V2. And here in our command window, let's get this up here. Here you go. We also shown the minimum voltage with the current range from 0 to 1 is negative 370.4, and maximum voltage with current range from 0 to 1 is 248.6 volts. And here's the results for the resistor, maximum voltage, minimum voltage, average voltage. So the good thing with this code is that pretty much any number you use within the limits we are given, which is in between negative 1000 to 1000, any number will work unless you go lower or above these limits. And also another limitation on this code is that, as I said before, we can only work with 2 voltages, and 3 resistors. Anything different, even if you're able to get a result using like numbers, you would get something incorrect. So we can do a second run and we can try different numbers. Let's say the first one is going to be 115. The second one is going to be 135. And the third one 50. And let's say 3 and 6. And there you go. Within seconds, we have our result. And another plot, as you can see, different from the first one. Also with minimum being red and maximum being blue. And here you go. All our numbers with resistor value, maximum voltage, minimum voltage, average voltage. Now, it's interesting because this code could be used today easily because let's say an engineer needs to get a result fast. It's so easy. You don't really need to do anything. You just have to put 5 inputs. And that would save a lot of time. And let's say you're working on a circuit and you don't know if you actually did anything right, if it's everything working properly. You can just run this and within seconds. And if you're actually going to test this with something else, you might have to just get everything, all the information, and then run. And so it wouldn't work as well, not as effective and fast. Now we can run another one. Let's say we can put something, let's say 155, 120, and let's say 45, and 3, and 6. And there you go again. I believe like we did different trials and it seemed to work fine. And there you go. We have everything. So that's it. Our code is working really well. Again, it works perfectly with this type of circuit. Unfortunately, we can't use with some anything different, but it's really good. Thank you very much for the attention, for the time. It's been a lot of fun. I hope you all enjoyed it.